from a migration approach perspective. So here's how I kind of look at these things and would give you the guidance to do. First of all, super important to understand the cloud services model itself. Okay? In this session, we're going to talk about the considerations, but if you're not sure yet or you're not comfortable with the specifics of cloud services, check out the Cloud Variations workshop. That's the first one that we did. It is available or will be available on demand. And you can watch sort of Corey go through the specifics of cloud services. Actually, I think it was Tyler. Sorry, Tyler Dirksen did that one. And so once you have that understanding, now we can talk about that consideration. So for the purposes of this session, I'm going to assume that you kind of understand web roles, worker roles, and so on and so forth. So we have the web, we have the worker roles, we understand what they do. We also understand the differences in configuration and communication and what we need to worry about there, or more importantly, what options are available for us. For example, configuration. We know that it's no longer just web.config for web applications. We actually have the service configuration where we can actually put in variables that we have access to change from the portal that actually live outside of the code. Fundamentally important to the architecture of your application, but kind of the things that you need to know before we have this particular session. And then communications, we're talking about things like, hey, available to us are queues for communication, or the service bus for communication, and how does that factor in, or what's available feature-wise for those. So once you have the understanding to all of that, then we can actually look at, okay, what are the different versions, or what are the different possibilities for deployments? How do we do a deployment? How do we do in-place upgrades? How do we do or switch between staging and production and all of these things? How do we take care of upgrades if we already have a production application in there? So as long as you understand all of that, this session will make sense to you. If you don't, make sure to ask questions in the chat. Francois and Tyler are there to answer those questions for you, to fill in the gaps while we go through this particular session. So basically, the general approach, though, once you have all that understanding, once you make all of those architectural changes, or decisions, rather, then you couldn't just basically, the rest of it is very simple. You add the Windows Azure specific code in there and certain custom code if you decide to go that route. You repackage the entire thing as a Windows Azure app. The nice thing is Visual Studio does a great job in helping you do that. Or if you have some of the other tools, if you're doing PHP or you're doing Java or any other platforms, the SDKs are available for you to help with that process. Repackage all your code, deploy your application now as a cloud service. So we're actually not going to focus on those specific steps, only because we've actually done them in previous workshop sessions. We'll focus on some of the considerations that you need to make in order to think about migrating an application from an existing on-premises to, rather than infrastructure as a service, to platform as a service. So let's look at things from a cloud architecture perspective, or sorry, from an application architecture perspective. First thing that we have to think about is, hey, do we use a cloud service or do you use Windows Azure websites? And you actually have to evaluate the options that make sense for the solution as a whole. And I say that only because you can actually mix and match cloud services with Windows Azure websites. And again, for those that didn't see the previous workshops, the Windows Azure websites is a brand new feature that's into the platform that actually allows you to deploy very quickly applications either through FTP or web deploy or Git or TFS or just from the gallery, just from the actual gallery on the portal, right? Or do you go the cloud services route, which actually then requires you to do what we just talked about, which is adding the custom code and configuration, repackaging your application, and then deploying it. Now, not to say that one is better than the other. What I'm saying is that one of those first decisions that you have to make is you have to decide in a platform as a services world, which one am I going to go for? Because it makes a difference for what happens next in terms of your migration process. Then we look at storage needs. Well, what do we actually need for storage? Now, again, this assumes that you've been with us for the previous workshops so that you know what table storage is, you know what the SQL database is in. So with this one, we have to think about, remember, we have options, not only in terms of options because each one technically does something in a particular way. But going back to those additional considerations we were talking about before, some of these have billing implications that we also need to think about. Now, this is actually the first time where us developers are thinking about cost, per se, as part of the actual application architecture, right? You would have, chances are, in some of your enterprise applications or your internal applications, you would have kind of basically went with what is technically best or what is available, right? It was never, well, you know, maybe I need to be somewhere in the middle because I need to worry about transaction costs, I need to worry about uptime costs, all of these things. Maybe you're used to working with infrastructure that's built flat, okay? The point is, in this world, the storage decisions that we make have all of those implications, as we said, scale, service level agreement, billing, so on and so forth. So each one of those we're going to go into. We'll also talk about, do I use local storage on the cloud service, or do I use blob storage? And we'll talk about what that means. But again, decisions that we need to make, because chances are the applications that you have today that you're thinking of migrating are using local storage. So they're actually writing data to hard drives as part of the machine that they're on. Now, in the cloud services world, this becomes a little bit of a problem because the cloud service itself, the machine that your code is running on, doesn't persist data, which means that when your application is recycled, all that data that you technically wrote to those hard drives are gone. Now, we have ways around that. We'll talk about that. But that's one of those things where in migration comes up mind first, because that's one of the things that's actually, if you don't understand how cloud services work, then that's one of the first things that's actually missed. You just assume, because you're used to, or at least your application is used to, the fact that the data will just be there if the server reboots. Or better yet, in this world, we're thinking scale, right? And we're thinking multiple instances. Well, if I'm writing to the local disk, I have a problem because that local disk is local to that one instance of the application. So as I flip around the different instances, all of a sudden that data isn't available to me. We also want to think about logging and diagnostics. Now, when we think about logging and diagnostics, this is one of those areas that are actually a little bit different in the cloud world. I love to believe that most of everything else is relatively the same between on-premise and the cloud, and then in the cloud you can actually just do more. But when it comes to logging and diagnostics, I'm going to say there are cloud-specific monitoring and diagnostics techniques, only because you have to be worried about that data usage and that transfer, right? Think about it this way. If you have a large log file that you're working with, and you want to read that log file, when you don't have direct access to the server, that log file is something that you have to download. Well, what if it's a gig of logs every time? You're going to download a gig every time just to read the one line, right? In the cloud world, when things are disconnected like that, you don't have that kind of premium access. So you want to think about, well, okay, how do I tweak my logging and my diagnostics so that it is actually easily available to me? Maybe you split it off into multiple small files. Or maybe you actually tone down the logging so that you're not logging everything. You're only logging things that you actually probably care about, in which case you're reducing the amount of data that's going across the wire, in which case now it makes it a lot easier to work with. Now, the nice thing is that Azure actually has tools to help you do this, one of which is the Windows Azure Diagnostics. Right? So that's a module that you can use right away. I have a link on there for you, aka.ms/WAD, that you can actually go in and see how to use Windows Azure Diagnostics, what you can use it for, and that's probably one of the first things that you actually want to look at. Especially if you have your own logging mechanism right now, compare it with what Windows Azure Diagnostics does and see whether you can leverage that relative to using yours, unless, of course, the one that you already have is in tune to some of these principles that I was talking about before, in which case you might as well just keep it. For those of you that are using System Center or want to use System Center, this one is a nice one. The System Center Windows Azure Management Pack actually allows me to monitor applications within a Windows Azure cloud service. So if you're already used to working with System Center, that's one of those things where you don't have to change. You can actually just change the management pack and boom, now you have the same information that you're working with. It's not as easy as I just said it, so check out aka.ms/SCWAMP for more information on that one. In your storage account, Now, you heard me talk about storage account in the previous session when we were looking at it from a virtual machine perspective, but as we'll see shortly when we talk about actually putting our binary data somewhere, hopefully you're going to modify it to use your blob storage. Now, your Windows storage account has analytics that come with it that also allow you to have logging and diagnostic capabilities. So then you say to yourself, well, if I can leverage some of these that are already in there, do I need to be doing it in my application level, which for all intents and purposes is duplicating the data, and then subsequently, potentially, there might be an additional cost, or you have to go downloading things when you don't actually need to, right? So different things. It's unbelievable to me as I talk to developers how logging and diagnostics is one of those things that nobody cares to look at, because you kind of just assume that you could just use your own, and you can. There's nothing wrong with it. All I'm saying is that these things are specifically optimized for the cloud environment. It's probably a good idea to take a look at it to see whether you can easily implement it in your application. Of course, when we're talking on the SQL side, there's also the database connection management that you can check to make sure how your connections are doing, their timeouts, their retries, and whatnot. Again, these things matter because that SQL server that you might be connecting to, the Windows Azure SQL Server or a SQL Server in a virtual machine, those may have a different uptime, and granted, they're going to be up as per the SLA, but just because your app is running on, you have to keep in mind, that your app is running on one VM, those ones are running somewhere else, and so you want to make sure that there's that retry capability, whereas on premises, you may have just assumed that it'll just work, right? Now, retries and reconnecting and all that kind of stuff, that's just general good practice. But I know many developers that actually work on internal applications where, it's sort of assumed that that would be the case, and so you don't really look at it. In this case, I can tell you it's not the case, in which case you specifically want to look at what logging and diagnostics actually looks like. Let's think about it from a testing perspective now. Testing is an interesting thing when it comes to cloud services because, again, you don't have specific access to that virtual machine. So how do you test an application that you're migrating over? You have to actually get used to testing this application in what's called compute and storage emulators. When you download the SDK, when you install the SDK, you actually have the capabilities built in there to test the application as if it were running on Windows Azure. So the compute emulator, for example, will give your application an idea of what it feels like to run in the Windows Azure environment as a cloud service. And you can actually even simulate multiple instances running, what happens when things go down, so on and so forth. The storage emulator, again, mimics queues, blobs, and tables in your storage account to give your application an idea of what it feels like to work with those. Now, of course, these are emulators, right? So as much as they are close, or as much as they simulate the actual functionality, they in fact are as close as possible. So how do we take into account testing, especially of an application that we're migrating to ensure that things are working? Best advice I can give you on that one is you're going to test everything in the compute and in the storage simulators first, okay? Things are working there, perfect. Now, don't move everything over right away because there's still a couple of, we'll call them technicalities or minor differences between them that you're going to want to check. So what do? Leave your application running in the compute emulator and move your whatever you have in your storage account, in your tables, and in your blob storage and in your queues. Move that over to your actual live Windows Azure account. Now you're going to test compute to your live storage account and see how that works. If all goes well, and hopefully it should because relatively the code is the same, right? Again, there are differences, I know. Now you say, okay, I'm going to now take my application out of the compute emulator. I'm going to deploy it into staging. Now again, for those of you that joined us on the Cloud Variations workshop, the Windows Azure in a Nutshell workshop, you'll know that staging is just another slot in Windows Azure where you can do some of your testing. Technically, it is live, right? So you get a little, or I should say a large GUID, cloudapp.net. And technically, anyone you give that URL to can go in and check out your app. What you want to do in staging is do all those last bit of tests, so performance tests or connectivity tests or whatever, to make sure that your migrated application actually works. Okay? So you're going to do that in staging environment with your live storage account. And then, last but not least, put up or do your swap between your staging and your production environment. And now your application, your migrated application, has gone through all the various different levels of testing to ensure that functionality that you know works on premises will now in fact work when moving it over, right? So if you kind of get the general gist of where this process is going, is you're changing little bits at a time from its current on-premises configuration to its cloud configuration. And that's actually the general theme of any kind of migration process you're going to do to platform as a service. Whereas you heard Richard talking about and you heard me talking about in the previous session, in virtual machines, you can literally forklift your VHD, move it over, you're good to go. Cloud services, not so much, but that's actually intentional. It's intentional so that you're not configuring the environment to work as you had it, bad habits and all. You're going into a controlled environment where now your application, technically you're going to look at it as you're changing your application to meet the environment. But ultimately what you're doing is you're actually modifying your application so that it's optimized for the environment. You might look at it as semantics or optics or whatever, but that optimization, which is what we're going to spend the rest of the time talking about, is actually where you're going to get the value out of cloud services, right? Otherwise, if you're not going to do anything, sure, you can run your application as a cloud service. It would probably be better and easier to manage than your on-premises, but you're not actually leveraging the value of cloud services. So before I move on to that, I want to make sure that you have these couple of resources when it comes to testing and diagnostics when you're migrating over. One of which is the troubleshooting best practices. Now, interestingly enough, it talks about troubleshooting, but I want you to think about troubleshooting in this case for migrating applications as actually proactive debugging. Okay? So you want to look at how to troubleshoot because you want to anticipate something of technically you have a completed application, right, that you're migrating over. So anything that doesn't work technically is a bug or something that you have to go and troubleshoot. So if you kind of look at these best practices ahead of time, you're kind of going to get an idea of how to look at maybe even solving some of the problems that you may have before they actually become problems. And then there's also testing, managing, monitoring, and optimizing. Again, that's another great resource that actually walks you through some of the things that you have to worry about or think about when you're migrating in each and every one of those. Okay? And don't worry about writing those URLs down right now. You'll have the video on demand. You'll also have the links available to you in the description of the video. So you can actually just double click on them when the video goes live on demand. But in case you actually wanted to go there earlier, you have those on the screen, and we'll go from there. Continuing on, we want to look at non-functional requirements. Now again, sort of thing that as developers we don't necessarily think about, but in this world we want to think about because we actually have to, it's almost like building in these features simply by thinking about where you're putting all the different pieces of your solution. You are in fact implementing these non-functional requirements. You as a developer might be looking at it and saying, well, okay, let's take for example storage. I think we should use storage because it's actually better from a scalability perspective. Or it's better because the API is ridiculously easy to use and I can just read and write things. What you're actually doing, or you can look at it as what you get out of the box, is high availability. You look at it from a disaster recovery perspective. Storage, for example, you have all of those extra copies of the data. Should something happen in the data center, right, you flip over to a different data center, you don't change your application, the application doesn't even know. More importantly, though, the disaster has been averted. Right? So I'm not going to delve into too much detail for these ones, but I just want to make sure that you understand that when you're making these development and these architecture decisions for migrating over your application to cloud services, that you do in fact keep in mind that with each part or each service that you're going to use, you want to make sure that you look at high availability, disaster recovery, and security. Let's look at specifically storage, because naturally, as you go through, applications themselves are only part of the equation, right? If you think about it, most of the applications that we build these days are doing some sort of storage, whether it's data storage or binary storage, it doesn't matter. They're doing some sort of storage, which means now we have to think about, okay, where do we move all of these different pieces and how do we build them into the application? So let's think about what we need to consider. We need to consider what type of data are we actually storing, right? How is the data going to be accessed from the migrated application? How do we upload existing data? So how do we migrate our data over? Again, some of these things, depending on, let's say, for example, if you have terabytes of data, that might potentially change how you migrate your application. For example, you might say, rather than uploading all of our data today, maybe we'll only upload a portion of it, or maybe we won't upload it at all, and we'll actually connect it, the cloud service, back onto our on-premises database. Okay? Different things like that is what you want to consider. So when we look at comparing table storage to SQL databases, which chances are probably going to be your two most common ways of looking at storing data, you can look at these things in multiple different ways. I think to pare it down or to make it the easiest way to understand, if you have large data sets, but you don't need to do any data processing, or it's kind of like just straight reads or very straightforward to work with that data, table storage is definitely the way to go. It is cheaper, it's faster, it's scalable. Again, see the Virtual Dev Camp or the Cloud Variations workshop where we talk about these things, right? But gives you a very easy way to get working with your data. Now the thing is, though, if you switch from whatever you're using right now, if you want to use table storage, that's now where this migrated application of yours, or the application that you're working to migrate, that's now when we need to start doing some code changes. Okay, it's not as simple as bringing it over to a Windows Azure SQL database or a SQL server running in a virtual machine, where you literally could just change the connection string and you're good to go. I say that there are a couple of complications that we'll get into when using Windows Azure SQL databases, but again, it's one of those things where you're making these decisions. You want to make sure you're making these decisions from both a development perspective, from an application architecture perspective, but also from all those non-functionals that we talked about. Okay. Another thing we want to think about: blob storage versus SQL database. Some of you are using right now your SQL database to store data. So let's say you're using FileStream and you're storing binary data within your database. Using Windows Azure SQL databases, that FileStream option is not available to you. Okay, so it just doesn't work. It's not there. It's not supported. So you say to yourself, well, okay, but I need that functionality. So the question I ask of you when we think about migrating the application over is, do you need your binary data to be in your database? Or do you need what feels like that, and you can actually store your data in blob storage and then stick a URL to your blob storage item in your database, and effectively your application just needs to know to go look at that URL instead of trying to get the data from the actual database. Right, so the functionality is possible, but here's what you've done by switching over to using blob storage and then writing the URL into your SQL database as opposed to actually having the binary data in your database. A, you've reduced the cost of your database, which then subsequently makes the cost of the database itself cheaper, because you are in fact paying for Windows Azure SQL databases. You're paying for the one, or you're paying for the space that's occupied by that database. More importantly, by putting things in blob storage, now each individual item that you're putting in blob storage is individually scalable depending on the demand that's coming to it. So now, moving over to blob storage, you've effectively made your object that much more scalable and your application that much more performant. Okay? So different things like that you want to think about as you start to look at the individual pieces of your application. So then you might say, okay, well, what if my application needs to, or today, stores things in local drives? Local drives, as we went through before, aren't persisted in a cloud service. So we need to think about things of how do we mimic that, but yet still keep it persistent. So there is actually a feature called Azure Drives, where you can actually take a portion of your blob storage and attach that to your cloud service, give it a drive letter. It feels and acts to the application like it's part of the server, but your information is in fact in blob storage, which still gives it that health and the stability, the high availability, recovery, so on and so forth. Now the problem with that, of course, is that because you've taken out a chunk and given it a drive letter, that chunk exists as a single application now, or I should say a single object. So I actually can't go in directly into that file and grab whatever file I want from that, effectively from that drive. But what if my migrated application needs to have that capability where I need to have access directly to files from the application or from outside the application? That goes back to those considerations I had on there before, where you need to think about not only what data am I storing, but how am I going to access this data? Do I need to access it from just Windows Azure environment, or can I access it from the outside? Okay, different things you want to look at like that. So here's basically the general approach to actually moving over into the, we'll call it Windows Azure SQL databases, as almost like forklifting your database the way it is today, no code changes or anything like that, and moving that over into Windows Azure. First, you're going to look at removing the dependencies for the non-supported SQL features, like file stream, like replication, things like that. Then you're going to look at removing the dependencies for data types or data object types. So think about these as, I was going to say linked servers, but those are available now. Think about these in terms of very specific queries, or some of the functionality actually like spatials and all those that don't work the same way. Okay? And then you want to think of adding functionality for Windows Azure SQL databases like federations, for example. So let's say you have a database that is gigs upon gigs upon gigs of data. And there is a logical way that you can think of to separate all that data out. So in order to make your Windows Azure SQL databases more scalable than just having the one database, you can actually use a feature called SQL federations to basically be able to shard out or split out your databases into multiple databases, but yet have your application think that it's all one database. Why do we do this? Well, again, if you move things over the way that they are, things will work. Is it as optimized for a cloud service environment? Probably not. That's one of these things where if we think about federations, we could technically leave the database the way that it is. But you go in and you add federations, now you have the ability to scale each individual database. And actually, the smaller you get these databases, the faster they are to replicate over to some of the other backup replicas. And you actually start getting more of that scaling functionality because the databases are in fact smaller. So it's a lot easier to manage. Again, if you don't do that, things will still work. This is optimized. Okay, so then, like I said, we go in and we make the code changes now. So we made the changes on the database side. Now we need to make the changes on the code. Now the code changes may actually be as simple as just change the connection string if you're not using any of those above things. If you're just using the standard SQL features, or you're using just the standard database objects, you could just go in and change your connection string. But in fact, if you are using all of these additional features, there may be code changes that you need to make there. Or if you want to add additional features, federations, for example, then you're going to make the code changes in your application, and then that part is done. Now, next part of that, we think about how do we actually optimize the data transmission, right? Because what we want to make sure is that we keep things minimal across the wire, if you will, even if it's between, I should say, internal to the data center. So between the Windows Azure SQL database and your application, which is technically within the Windows Azure data center. So here you want to think about maybe on premises you bring back an entire record set for a query, or you don't necessarily use all of the where clauses that you can, or maybe you don't ask for all the where clauses to really bring it down to the data set that you actually care about. In this world, you may want to do that, right? The less information you send across, the faster queries execute, the faster applications get and do what they need to do. And there you go. So once you've done all those changes, then you say, okay, well now how am I going to migrate the actual data itself? And you want to think about Am I going to export my database? Am I going to script it out and then execute that against the server? Am I going to, am I going to use a tool that I'm familiar with? Am I going to run my own app, if you will, build my own app to move things across? That's the migration process that you want to think about. You build the packages or applications, depending on how you're going to actually do that. Run the process, and now you have your data moved over. But you needed to have gone through all of that because, again, you saw in Richard's example, because he had a virtual machine or a SQL server running in a virtual machine, you literally could take the database as it is today, move it over, or detach it from one, attach it to the other, done. You don't need to go through all of this stuff. But what then you don't get the advantages of, and you saw actually in the chat as we were going through, you don't get all these powerful features, if you will, of databases as a service, right? And the capabilities of geo-replicating all those databases and making sure that the high availability is there, the clustering, the monitoring, all that, not there. Or there, but you have to do it yourself. So don't underestimate. It could actually be that while you may think to yourself, you know what, it's going to be a lot easier to move this application if I just put the database in a SQL server running on a virtual machine. But once you move into Windows Azure SQL databases, or I should say if you can move into Windows Azure SQL databases, I want to say that about 80% of applications can in fact go down this route. You'll actually see the benefits come back in terms of A, what you don't have to manage, but also B, the capabilities in terms of scale and what that will then imply for your application. Okay, now let's look at apps that use local storage. Right? Again, we want to make sure that we don't write to the hard drive, to the local hard drive, and then we have the options of either using Windows Azure drives or we want to use blob storage to do that. Right? What you want to think about is, in my application, do I want to share the data across the instances of my application? Now, you may only have an instance or one instance of your application today. That's fine. Tomorrow you have more. So if you think when you migrate your application, you think, hey, this might actually be an opportunity for me to look at my application and say, this probably served me well today, but maybe I'm thinking of growing it, or maybe this is actually a good opportunity to get that growth in there or potential for growth. Now I'm thinking, okay, well, I need to find a way to make sure that I can communicate with all those instances. Writing to the local storage, not going to do that for me. Then the other thing that you want to think about, and this we went through in the first session of the Cloud Variations workshop, where we talked about the cloud being this idea of enabling not only applications that you have today, but also devices. Right? So today your application may just be its own application. But as you think about where it can go, right? Can you see device additions to your application? Let's say you are writing a website or you're writing an API. Can you see something other than a website consuming it, like a phone device or a slate or a Surface or whatever it might be, right? So now you're thinking to yourself, that method of storage that I have, I need to make sure that I can actually access it from outside the Windows Azure platform. So that, again, will kind of push you towards blob storage in this case. That will give you all that functionality and in turn also make things a lot better for your application. Now, some of you might be doing caching in your application. If you're not doing caching, this is probably a time where you want to consider doing caching, only because that will, A, make your application a lot faster. But more importantly, again, if we're thinking about scale and if we're thinking about future opportunities, of the most important is how performant the application is and how much can you expand it past its current infrastructure, let's say, or its current architecture. So that's where actually caching comes in. And if we think about the types of applications that we store in cache, or this type of data that we store in cache, you want to think about it as things like reference data, things that you need quick access to that probably don't change that often, right? You want to think about it in terms of activity data. Maybe things that actually does change quite often, but you need it in a very snappy way. Or reference data, which is actually a bit of both, or things that you actually just need to work with and resources that you need to work with your application. So rather than writing all those to blob storage all the time, or rather than reading from blob storage, reading from databases, which technically are slower, you now have these capabilities that you may not have thought of before in terms of caching, where you could, if you have one already, then you could technically use your own, in which case I would say when you're evaluating migrating over, you want to think about, does my caching provider provide the same functionality as the Windows Azure caching functionality? And the reason why I say that is because the Windows Azure cache sits outside of your application, which means it's yet again one of those features that we manage for you. So if we're managing for you that resource, then that means yet again it's one less piece of infrastructure that you're worrying about. You can actually just read and write as you need. So once you kind of make that distinction between should I use my own or should I use the one that that is available to me in Windows Azure, and let's say you say, okay, let me use the one that's in Windows Azure. Now you also have the option of saying, well, do I go with a shared one or do I go with one that actually is a caching role? The differences, of course, between the two is one sits outside of your infrastructure. It's managed by Windows Azure. It uses its own functionality, and you just read and write to it as a service. Whereas the in-role caching functionality actually uses either a dedicated cloud service that you say, this is my caching role, or it uses a portion of your existing roles, your existing web instances or your worker instances, and it uses that. Now, the nice thing about that is that that's infrastructure that you're already paying for, so you can use it almost for a multitask. Or you might say, well, yeah, you know what? I don't necessarily want to rely on that infrastructure because it's doing other things for me, so I'm going to go ahead and use the shared one. The point of that being there is that as, again, you think about where migrating your application, and especially if you don't have caching today, you want to ask yourself, how do I make this application as fast as possible, and how do I make this application as scalable as possible? Caching does that for you in terms of your data because it actually allows for that data to sit outside of all of these other data mediums that aren't as fast as cache. Actually, cache is in memory, so you know that it's the fastest option of all of the options that you have. So as you're migrating, again, cache, the beauty of it is not something that you need to do day one. You can come back and add that in a next iteration, next iteration, next iteration, each time tweaking back and forth. But it's definitely something that on your migration process or your roadmap, you want to make sure that at least somewhere you hit that in there. Let's talk about communication mechanisms or considerations between different portions of your application. What you want to do here is you want to look at what your current architecture is, and you want to see where there are opportunities or possibilities for using communication mechanisms like Windows Azure Queues or the Service Bus. Now, again, we talked about the specifics of these in the other workshops, but what you want to think about here is how do I get my application to a point where it's as loosely coupled as possible? Loosely coupled means that I have the ability to mix and match different services. It means that I have the ability to scale different parts of my applications differently than other parts of my application. And it also enables that device scenario that I was talking about, and generally just these days at least, really good development practice, right? So you want to think about loosely coupled, but also now scale, which is what I covered before. So when we're thinking about these communication considerations, you want to think about where in my application, and if your application is using MSMQ today, MSMQ is not available in Windows Azure. So you want to think of something that will be there to replace it. These two, they don't do the exact same thing, but they do a pretty good job of making sure to communicate. Long story short, on the queues, you want to think about if I have multiple instances or if I have multiple parts of my application, let's say I have a web front end and a back end, rather than having the two talk to each other, I want to make sure that I retrofit that to use queues so that I can rely on the service availability of the queue to make sure that if one side of my solution goes down, then there isn't anything preventing the other side from continuing to go. A perfect example of that is, if you have a front end that takes in orders or takes in jobs from an operator, let's say, and the back end that actually executes those. So if you have a queue in the middle of that, then let's say what actually executes the jobs goes down, you can still continue to get interaction from the user. One has nothing to do with the other. Or vice versa, if the front end to the users is down, means you can still process what has gone on before that happened. And one has nothing to do with the other. And ultimately, where you have the possibilities in your application to decouple these, the migration time is a good time to do that, because you're already in the code, you're already making changes. You want to think about how you can get queues and or service bus in there to actually just make that communication a lot faster. So let's recap the migration approach. Big green there on understanding the cloud services and the various different configurations and considerations, right? But most importantly, once you have the decisions down packed in terms of, how am I going to distribute my web and worker roles? What do I need to think about in terms of configuration? What opportunities do I have to make the different parts of my application communicate with each other? So that's the queues and the service bus. How am I thinking about in terms of deployments? So am I thinking about deploying multiple parts of my application, or is it just the one? Once you have all of these things, and you'll notice a lot more considerations here than what you had to go through when you're migrating to a virtual machine, because, well, all of these things you have technically could contain within the one virtual machine. The nice part is, though, as much as I called the session migrating to platform as a service, it actually, a lot of it applies to virtual machines as well, or infrastructure as a service. Because you could actually move your application to a virtual machine, but all of these additional services, the blob storage, the caching, all of that, can in fact be using Windows Azure services. One does not negate the other. But it's fundamentally important as you're moving to platform as a service, because you do actually want to take advantage of what the platform has for you, rather than kind of defaulting to the virtual machine where effectively you have to supply everything of your own. So hopefully that kind of gives you an idea of what to look at when you're migrating to platform as a service. As always, questions in the chat. We're going to take a little break. We're going to flip over to a session that Tyler is going to do that actually talks about now putting the two together and how you can actually have parts of your application as infrastructure as a service and running in virtual machines, part of your application running in or platform as a service mode or cloud services, and what you actually need to do in between them to make all that stuff happen. So stay tuned after the break. We'll be right back.